So, good evening, everyone. Today is the problem solving session 5 for the course Spectroscopic Techniques for Pharmaceutical and Biopharmaceutical Industries. I'm your TA Vidushi. So, in this session, we will discuss about atomic spectroscopy. So, what do you mean by atomic spectroscopy? The study of the electromagnetic radiation absorbed and emitted by an atom. That is your atomic spectroscopy. So, on right hand side, you are seeing the spectrum of the hydrogen atom. So, in the previous session, we have discussed about the spectral series observed for the hydrogen atom that includes Lyman series, then comes your Balmer series, then comes your Paschen series, then comes your Bracket and Fund series. So these are your different series for the hydrogen atom. So see this Lyman series. So in Lyman series, the transition occurs from the first orbit to the higher orbit. That is from 2 and n1 will be 1 and n2 will be 2, 3, 4 and so on. And the Lyman series is obtained in UV region. Then we discuss about the second series, that is your Balmer series. In case of Balmer series, it is obtained in the visible region and here the transition is from the second orbit to the higher one. Therefore, n1 will be 2 and n2 will be 3, 4 and so on. Then comes your other series, that is Paschen series. Here it is obtained in near IR region and here the transition occurs from the third orbit to the higher orbit. Therefore, n1 will be 3 and n4, n2 will be 4, 5 and so on. Then comes your Bracket series. Here it is obtained in the mid IR and here n1 will be 4, that is transition is from the fourth orbit to the higher orbit. Therefore, n2 will be 5, 6 and 7. Similarly, for the Paschen series, n1 will be 5 and n2 will be 6, 7 so on. So here it is obtained in far IR and transition is from fifth orbit to the higher orbit. So Lyman means UV, Balmer visible, Paschen and Bracket and Fund are all in IR, but Paschen is in near IR, Bracket is in mid IR and Fund is in far IR region. Now these are about the spectral series. So in the left hand side you are seeing the atomic spectrum. So atomic spectrum is also called as the fingerprint of an atom. Why? Can anyone tell why the atomic spectrum is called the fingerprint of an atom? Because here if you see, this is an atomic spectra of hydrogen, neon and iron. And you see the atomic spectrums are different for all the three atoms. So atomic spectrum will be different for different atoms, therefore they can be easily identified by looking upon the atomic spectrum. That's why they are called as fingerprint of an atom. Even they are also called as the line emission spectrum because in this case you observe the simple lines and the light that is emitted will be given off. So from here you can identify what are the atoms from the atomic spectrum. That's why it is called as fingerprint of an atom. So let's solve some questions related to this. Find out the minimum energy required to take out the only one electron from the ground state of lithium plus. So what will the minimum energy to take out the electron from the lithium plus ground state? 13.6, 122.4, 25.3 or 67.9? Anyone? So we know for lithium, the atomic number is 3. So the minimum energy required to take an electron is given by 13.6 Z square. So substitute the Z, we know Z is 3. So it will be 13.6 into 3 square, that is 13.6 into 9. So this is a 9. So 13.6 into 9 will give you 122.4 eV. So that is the minimum energy required to take the 1 electron from lithium plus. Moving to next, calculate the wavelength of a photon emitted when an electron in hydrogen atom makes a transition from n equals to 2 to n equals to 1. So what will the answer to this? So it will be, we know the Rydberg's formula, that is 1 by wavelength is equals to R into 1 upon n1 square minus 1 upon n2 square. So substitute the value of R we know it's a constant, so it is 109677 centimeter inverse. Now the transition you are seeing, it's from n equals to 2 to n equals to 1. So substitute the value of n. So n1 will be 1. So 1 square and n2 will be 2. Sorry. Now solve this. So after solving it, you will get 2.27 into 10 minus 6 centimeter. So that will be the answer to this question. Next, if an electron makes a transition from the 7th excited state to the second state in the hydrogen atom sample, find the maximum number of spectral lines observed. So, how can we solve this? See, here you are talking the 7th excited state. What does it mean? See, here you are having a ground state. Then there will be excited state first. Then so on, like excited state 2, 3, 4, 5, 6, and this will be 7th excited state. That means it is 7 plus 1 for the ground state, so it will be total 8. So in this, your N1 will be 2 and N2 will be 8. Now just tell me. So that's what is the formula to calculate the number of spectral lines? So it will be N2 minus N1 N2 minus N1 multiply by N2 minus N1 plus 1 divide by 2. So your N2 will be 8, N1 is 2. So we are just substituting the values. So 8 minus 2 multiply by 8 minus 2 plus 1 divide by 2. So it will be 6 multiply 8 minus 2 plus 1. So 5. 6, 6 plus 1, 7 upon 2. So it will be 42 by 2, that is 21. So the maximum number of spectral lines observed will be 21. So this formula you should remember to calculate the maximum number of spectral lines. N2 minus N1 multiply N2 minus N1 plus 1. Now moving to next. The wavelength of Lyman series lies in visible, UV, radio waves or infrared. So in Lyman series, what is the transition? Vijay? Transition occurs from which orbit to which orbit? Lyman is the first series, so N1 will be 1 and N2 will be 2, 3 and so on. So we have already discussed its UV region. It is obtained in the UV region. Next, the energy of an electron in a hydrogenic atom with a nuclear charge Z varies as Z, Z square, 1 by Z or 1 by Z square. So it will be Z square. Why? Because it is 13.6 into Z square. So Z square is the answer. Next, the potassium salts are placed in a Bunsen flame to obtain the line spectrum. The color of the light emitted is yellow, violet, green or white. So for the potassium salt, it is violet. Why? The color of the light emitted depends upon the nature of the substance. For example, if you have sodium salt, it is yellow and potassium gives violet. Next, alpha line of Balmer series corresponds to shortest wavelength with N2 equals to 2, longest wavelength with N2 equals to 2, longest wavelength with N2 equals to 3, or shortest wavelength with N2 equals to 3. So what is alpha line? So alpha line means it is the first line of Balmer series. So Balmer series we know N1 will be 2 and N2 will be higher than 2, that is 3, 4. So N1 plus 1, that is 2 plus 1 is 3. So that is your alpha line. Next, the wavelength of a certain line in Balmer series is observed to be 4341 angstrom. To what value of n does it correspond? So it will be for 4341 angstrom. 1 by wavelength is equals to So it will be 1 by wavelength is equals to RH 1 upon n1 square minus n2 square. So they are talking about the Balmer series. Balmer series we all know. Here the transition is occur from second orbit. So it will be 2 and this, and you have to calculate out. So you know wavelength it is given, it is 4341 angstrom. So we will convert this angstrom into centimeter. So for that we multiply by 10 minus 8 centimeter. Or we can simply write 4.341 into 10 minus 5 centimeter. Now for the formula we note 1 by wavelength. So that means 1 upon 4.341 into 10 minus 5. That means it will be 230 to 2.3 centimeter inverse. So this is the value 1 by wavelength. So now put this in the Rydberg's formula and calculate the value of n. So it will be, now this value we will substitute here. So it is 230 to 2.3 equals to 109678 upon 1 upon 2 square is 4 minus 1 upon n square. So we can write 230 to 2.3 divide by 109678. That will be 0.25 minus 1 upon n square. So this value will be 0.2099 equals to 0.25 minus 1 by n square. So 1 by n square will be 0.25 minus 0.2099. So it will be 0.0401. So this is the value for 1 by n square. Therefore, n square will be 1 upon 0.0401. So this value is nearly 25, that is, it is 24.94. So what will n? So n will be under root of this, so it will be 5. So the correct answer will be 5. Next, calculate the wavelength of the first line and the series limit for the Lyman series for hydrogen. And R you have to use 109678. So first line and the series limit for the Lyman series. Anyone? What will be the answer? Or how we will solve this? What do you mean by the first series and the limited series? For the Lyman? Bhumika? First line and the series limit for the Lyman series. What is Lyman? Lyman means transition is occurring from this second energy level to the lower level. So, for the first line, but use Rydberg's formula. R is already given. We have to use 109678 upon. For the first line, we know it will be 1 square minus 2 square. So it will be 10967 into 3 by 4. So after solving it, it will become 1.215 into 10 minus 5 centimeter. Now this was for the first line. Now we have to calculate for limited line. Limited line means your n1 will be infinity and n2 will be 1 as it is a Lyman series. So now substitute the value. So 1 by wavelength will be equal to 109678 multiplied by 1 square minus 1 by infinity. And 1 infinity square. So what is infinity? It will be 0. 1 by infinity will be 0. So 1 by wavelength will be 109678. So therefore from here wavelength will be what? Reciprocal. So it will be 9.11 into 10 raised to minus 6 centimeter. So this will be the value of wavelength. Or in angstrom, 911.7 angstrom or 1215.7 angstrom. Is this clear? Bhumika, is this clear to you? Bhumika Singh. Next, calculate the maximum wavelength of the Balmer series in the hydrogen spectrum. Calculate the corresponding wave number and R is given. Now for a maximum wavelength to be emitted, the transition of the electron should take place from the corresponding energy release, that will be minimum. And for the minimum energy, the transition of the electron should take place between the closest energy states. So if you know for the Balmer, your N1 will be 2 and N2 will be there for the closest energy state will be 3. So we will use this one. Now it will be 1 by wavelength. R was given to be, we have to use 1.097 into 10 raised to by 7 centimeter inverse into 1 upon 2 square minus 1 by 3 square. So it will be 1.097 into 10 raised to by 7 here the unit will be meter inverse into 1 upon 4 minus 1 upon 9. So what will the value after solving this? So what will the value of wavelength? Anyone? Bhumika, it will be 656. Yeah, it will be nearly 656 nanometer. Now, what will the wave number correspondingly? It will be 1 by wavelength. Just tell me what will the value in wave number? For 656, what will the value in wave number? Just reciprocate it. Wave number is 1 by wavelength. So 1 upon 656 into 10 minus 9 meter. So after solving it, it will be 1.5 into 10 raised to the 6. This will be meters. Or 0.152 10 raised to 7. Now next, calculate the Bohr atomic number. The radius of the orbit is directly proportional to, it will be n square. Moving to next, the difference in angular momentum of revolving electron in third orbit to that of sixth orbit is, what is the difference in angular momentum? Just tell me firstly this. Yeah, correct, Bhumika. So what is the difference in angular momentum? What is the difference in angular momentum? So it is given by nh upon 2 pi. So now we are talking from third to sixth orbit. That means it will be 6h 2 pi minus 3h 2 pi. So it will be 6h minus 3h, that is 3h 2 pi. But in answer, if you see 3h by pi, it is not 2 pi. So we can eliminate this. Now 3 by 2 is what? 1.5. So it is 1.5 h by pi. Option D. Moving to next, the angular momentum of electron in third orbit. Now you know everything. Which formula to use? nh upon 2 pi. Same. Use nh upon 2 pi. N is third. 3. H is 6.022 into 10 minus 34 upon 2 into 3.14. So once you will solve it, it will be 3.1 into 10 minus 34 kg meter square per second. So option C will be the correct one. Now, next, this you should carefully understand, because now then we will solve some questions to term symbols, then only it will be clear. So what is term symbol? The different electronic states of an atom or an ion is described by L or S in form of a term symbol. One term symbol can describe one or more microstates with the same energy. So what does a term symbol describes? It tells about microstates with the same energy, and term symbol indicates that the total orbital increment. So what is your L? L is your total orbital incrementum. Multiplicity is given by 2s plus 1. So your term symbol is denoted by 2s plus 1 L. So what is S? S is your spin. And 2s plus 1 is your multiplicity. L is your total orbital angular momentum. Now, here comes your J. And what is J? J is your calculate J as follows. If this I will come later. So before proceeding, how we can know the spin and everything? Let's take a simple S subshell. Here, both electrons are filled. So what does it mean? What is the spin here? What is the spin here? When in S, you have two electrons. See, for a single electron, the spin is half. And for the other, it is it's half and minus half, basically. So, for one electron, it's half. So, for two, it will be half plus minus half. That will cancel out. So, total spin will be 0 for the paired one. So, here, S will be 0. So, if you want to calculate the spin multiplicity, so it will be 2s plus 1. That means 2 into 0 plus 1. That will be 1. Also, how can you know about the total orbital angular momentum? So, just remember S, P, T. If your value of L is 0, 1, 2, 3. So, for 0, it will be S. For 1, it will be P. For 2, it will be D. And for 3, it will be F. And what about J? Let's take an example. Just see first, if the subshell is less than half filled, then you will use L minus S. If it is more than half filled, then we will use J equals to L plus S. And if it is exactly half filled, then we will use J plus S. So what does it mean? See, you are having this. Like just take example of D. So D has 5. C. Now you have see, in case of D, you can accumulate total 10 electrons. But now you have how much? 5. That is exactly half filled. So here you will use the equation L equals to S. So J will be exactly equal to S. So J will be equal to S. So what is S here? Total 5 electrons, and for a single one we know it is half. So it will be 5 by 2. So J will be 5 by 2. Now, if we have 6 electrons or more than that, that means now it has more than half filled. So we will use L plus S. This will give you the J value. Now, if you have suppose 3 electrons, then it is less than half filled because what is half filled? Half filled is 5. So less than half filled, you will use the formula J will be equal to L minus S. So this you have to remember for the term symbol. So for the term symbol, just remember it is given by 2s plus 1 L. What is S? S is your spin. 2s plus 1 is your spin multiplicity. L is your total orbital angular momentum. And how can we calculate J? L minus S if less than half filled. L plus S more than half filled. And J will be equal to spin when the subshell is exactly half filled. Like 5 in case of d orbital, 3 in case of 2 orbital. And also, how do you know L? For S, it's 0. For P, it's 1. D, 2. F, it will be 3. Is this clear up to this? Sriyansh Yadav, Khalida Banu, is this clear?
Yes, ma'am.
Okay. Now tell me what will be the atomic term symbol for helium if its electronic configuration is 1s2. So we know for the S, it is a 1s2. Now just tell me what will be the term symbol? Before moving to term symbol, just tell me what will be the spin here? What will the spin here? C for 1s2. We know we have to use this formula 2s plus 1 and J. So now what is S? Paired, we already discussed it will be 0. So spin multiplicity will be 2 into 0 plus 1. That means 1. So 2s plus 1 is 1. And for as it is S, so we know L is 0. So now we know it is 1s. Now what about J? J will be L plus S. L is what? 0. S is what? 0. Spin is also 0. L is also 0. So it will be 1s 0. So B D option is the correct one. Moving to next. Total number of energy levels contained in the term 3F will be, so this is given by formula 2S plus 1 multiply by 2L plus 1. Now for 3F, what is S? What is this? See, we discuss 0, 1, 2, 3. That is S, P, D, F. So it is 3F. So for F, we know L will be 3. L we know it is 3. And 2S plus 1 we already know it's 3F. That is your 3 is your spin multiplicity. So 2S plus 1 is your 3. So S will be 1. 2S equals to 3 minus 1, 2. So S will be 2 upon 2, that is 1. And L is no 3. Now substitute this value in this equation. So it will be 2 into 1 plus 1 multiply 2 into 3 plus 1. So it will be 3 multiply 6 plus 1 7. That is 3 into 7. That is your 21. So this will be total number of energy levels in 3F. Is this clear? Khalida Banu Shriyansh Yadav, is this clear? Or should I repeat? Is this clear?
Ma'am, you just repeat one more time, ma'am, please, ma'am.
Okay. Which one? The first one, the second one?
Second one.
Okay. So see here, you have to calculate the total number of energy levels in 3F. So let me take a new slide. C4 you have to calculate for the 3F. So the total energy level, it is given by the formula 2S plus 1 multiply by 2L plus 1. So what does 3F tells you? What does 3F tells you? 3F means 3 is your spin multiplicity. That means 2S plus 1 is your 3. So 2S plus 1 is already given that it is 3. So from here you can calculate S. So 2S will be 3 minus 1, that is 2. So S will be 1. Now to put in this formula we also need to know the value of L. So what is L? We already discussed 0, 1, 2, 3. For 0 it is S. For 1 it is P, 2 it's D and 3 is F. So for F, what is the value of L? 3.
3.
So now we know S is 1 and L is 3. Now we have to substitute these two values in this equation. So see here, we have just simply put 2 into 1 plus 1 multiply 2 into 3 plus 1. That is 2 plus 1 3, 2 into 3 plus 1 7. So 3 into 7 is 21. So that's the answer. Is this clear?
But this A, B, C, D, what will be the answer?
What is ABCD?
No, no.
Where?
Excuse me. You just go back, ma'am. You just go back. That slide.
Yeah.
Yeah. For this,
But
what
just
are
you
the
have,
possibles in that question? You're
we are
telling the
doing,
total number of energy levels contained in the term, right, ma'am?
yeah.
There is no options. We have to calculate and we have to give the answers, right, ma'am?
Yes, yes.
Yeah. Okay. 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 Okay.
Now moving to next. What are the possible term symbols for 1s to 2s to 2p1? And what is the ground state? So for the 2p1, you have to calculate term symbol and the ground state. See, for 2p1, you need to calculate term symbol and ground state. So how can you do? So can you tell me what is the term symbol for 2p1? 2p1 means what? In P, you are having only one unpaired electron. This is a 2p1. So what will the term symbol for this? Shreyansh Yadav, Khalida Banu, are you solving it? Term symbol for 2p1. See,
Ma'am, this is same as above or this is different, ma'am?
different. So this is the
Actually,
question.
now only I joined, ma'am. I don't know from where I have to calculate this and all.
Okay,
Now only I joined, ma'am. Later
okay,
only I joined. Okay.
okay. See, for 2p1 means we are talking about the p subshell, and here we are having one unpaired electrons. So the further term symbol, this is the formula. Now, for calculating the spin multiplicity first 2s plus 1, we need to know what is the value of s. So what is s here? For one unpaired electron, s is half.
Yeah.
So substitute this value 2 into half plus 1. So it will be 3.
Yeah, it is one.
Sorry,
Yeah,
2.
I understood that, ma'am.
Okay.
It is one only, na, ma'am. You should with this.
1 plus 1 is 2 now.
Yeah, yeah. But for that, the S value is 2 only. Every time it will be 2 only.
No, s value will be half here, na?
Half here only.
S is spin. If you are
Okay,
having one
okay.
electron, it's half.
Okay, okay, okay.
If it is paired, then it is 0 because half and minus half will cancel out.
Okay, okay.
Yeah. So 2s plus 1 is clear. Now,
Yeah, okay, ma'am. You carry.
okay. So here, they're asking what are the possible term symbols. So we know L value can be either 0 or 1. If it is 0, then it is S. If it is 1, then it is P. So option can be either it can be 2S or it can be 2P. So these are the possible term symbols. But what will be in the ground state? See, if the spin multiplicity is same, then we see what is the higher value of L. Whenever the spin multiplicity is same and you have to choose the ground state, so choose whose L value is highest. So in case of S and P, whose L value is higher? In case of P, so 2P will be your ground state. So the correct answer will be 2p and 2s, so possible term symbols. And for the ground state, it will be 2p. Moving to next, you have to calculate the term symbol when L is 0, S is 0. L is 0 and S is 0. So now tell me what will be the term symbol? So S is 0, so it will be 2 into 0 plus 1. 1. L0 means we are talking about S. So it is 1S. Now if S is half, then 2 into half plus 1. So 2 and L0 means S, that is 2S. Next, 1 and 1. So 2S plus 1. 2 into 1 plus 1. 3. Now L is 1. What do you mean? L1 means we're talking about P. So it will be 3P. Now tell me if L is 2 and S is 3 by 2. What will be the term symbol? L is 2 and S is 3 by 2. What is the term symbol? Khalida? Khalida Banu, what will be the term symbol? L is 2 and S is 3 by 2. Use this.
Yeah, 1 minute.
Yeah.
Four, ma'am. Hello.
Yeah. I am asking the term symbol.
Term symbol means which means I
2S
didn't
plus 1 L.
hear
In this
about it.
form, you have to tell me.
Yeah, this one only I applied, ma'am.
So 2S
2
plus 1 is
into 3 by
4.
2 plus 1.
That is 4.
Yeah, ma'am. Yeah, that is 4 only, na, ma'am.
But term symbol is this 2S plus 1 L. What is L?
This is L, na, ma'am.
L.
L.
L is 2. We know
L
S,
is 2.
P, D, and F.
Yeah, 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 yeah. 2s plus 1 into, right, no, ma'am? That one only, na, ma'am?
No, no, no. See,
L.
L is total orbital angular momentum, na? So,
Okay.
term symbol is represented by 2s plus 1 into L. So, in this form, we have to calculate. So, we already know about the spin It is 4. But what will be
4,
the
yeah,
value
ma'am.
of L? As L is 2, that means 2 corresponds to D. So, it will be 4D.
Yeah, yeah, yeah. Oh, SPDF you are telling,
Yeah.
right, ma'am?
Huh. So, the term
Oh,
symbol is
the
4D.
Yeah, L represents the number of SPDF, right, ma'am?
The total orbital
S
angular
means
momentum.
0, P means 1, that
Correct.
only, right, ma'am?
Correct.
D. It is D,
Ha,
right?
ha. 0 is S,
Okay.
1 is P,
Okay.
2 is
Okay.
T, 3 is
Yeah.
F.
Yeah. Okay. Okay. Okay.
Now
So
tell me,
what you are asking in this, ma'am, regarding the symbol means?
I am asking what will the term symbol? Basically, you're calculating the term symbol, and term symbol is denoted by this. It's a
Okay.
general formula.
Okay. Okay. Okay.
Now tell me
So
if
why
L,
you are placing that L in downside, ma'am?
ha. So what just earlier it was earlier the L value was given to be 2. That means
Okay.
2
Okay.
corresponds to D. So the term symbol will be
Yes. Yes.
for D. Like that.
Okay. 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 Okay.
Now tell me if L is 3 and S is 2, what will be the term symbol?
L is 3.
Yeah, and S is 2.
L is 3. L is 3 means automatically it is F, right, ma'am?
Correct. It is F. And what is S
Okay.
equals to 2 means? The spin multiplicity.
S is equal to means 2 into 2 plus 1, right, ma'am?
Correct. So it will be
4 plus
5F.
1, 5.
Correct. So
5, right?
5F, that is a term
5,
symbol.
which is F. Okay,
Yeah.
okay, okay.
So that is a term
Okay,
symbol. Is this clear?
okay, okay. Yeah,
Yeah.
yeah, yeah. Clear, clear, clear.
Yeah. Now, what will be the ground state term symbol for D1?
SPDF. SPDF, which is D means 0, 0, 1, 2. 2, right, ma'am?
No, no, I will just, maybe I will just solve it first. See, D1 means you are having 5 subshells, no?
Yeah, yeah,
So 1 means you are having 1 unpaired electrons. Now,
yeah.
we need to calculate. Ground state term means in this form.
Okay.
This is a general formula, okay? So, for the ground state term, it's 2s plus 1 Lj. Now, what is 2s plus 1? As it is 1 electron only, so S will be half,
1,
half.
half, half. Oh, okay, okay.
We are talking about spin.
Which is 2. It's 2.
So, it will be 2s plus 1, that is,
2.
it will be 2.
2.
And what about L? L, you can, like in
L
this
is
case, you can
0, 1,
simply
2, which
calculate
is
it for
D,
a,
right, ma'am?
no, no, I will tell you, for a free and how you can do, like 0,
Okay.
1,
Yeah,
2,
yeah,
minus 1, minus 2. So, only one electron is in 2. So, write 2,
yes.
and how many electrons? It's 1. And plus, for this one, it has 0 electrons, plus, for this 0, it has 0 electrons. For minus 1, it will be 0, minus 2, it will be 0. So, only it will be 2, 2 into 1, that is 2. Now, see, for 2, what is the value?
D. L is D, right, ma'am? S, P, D, F, 0, 1, 2.
It will be D, correct. Then it
Yeah, D
is
only.
2D. Now, what will
Yeah.
be J? I discussed earlier, if your subshell is half filled, then
Okay,
J value is exactly same as S.
okay, okay.
If it is less than half filled, then it is L minus S. If it is more than half filled, then L plus S. Now see here,
Yeah,
D can accumulate how much? Total 10 electrons, but it had only one. So it is less than half
okay.
filled. Half.
L,
See, D can accumulate total how much? 10 electrons in total.
to, 10.
10, na? Like 2 in each subshell.
Yeah, yeah. Yeah, yeah.
So what is half? It's 5.
5, 5, 5.
But here it is only 1. So it is less than half filled. So we will use this formula. J will be equals to L minus S. What is L?
Oh.
L is 2
L is to 2
and S
minus
is
1 by 2. 1
correct.
by 2, ma'am.
So J will be 3 by 2.
3 by 2. Okay.
Now it is clear.
Yeah, clear, clear.
Now just tell me for D3 system. D3. Just solve and tell me.
It is also employed in the 2s plus 1 formula only, na ma'am?
Same. The term symbol,
Okay.
Gaussian term symbol, same 2s plus Lg in that form.
Yeah.
So what is spin here? What is spin here? Free unpaired electrons means spin is three electrons, and for a single it's half, so it will be 3 into half, that is 3 by 2. So 2s plus 1, it will be 2 into 3 by 2 plus 1, that is 2 will be cancelled out, 3 plus 1, that is 4. Now what about L? 0, 1, 2. So L will be 2 into 1 plus 1 into 1 plus 0 into 1. Rest of it will be 0. So it will be 3. And 3 corresponds to F. So it is 4F. But what about J? Is less than half filled. So L minus S. So L is 3. S is 3 by 2. So it will be 3 by 2. 4F 3 by 2. Similarly, solve for D5. So similarly for D5, S will be 5 unpaired electrons, so 5 into half. That means 5 by 2. Use formula 2s plus 1. So it will be 2 into 5 by 2 plus 1. That means 6. And what about L? L will be 0. So it is S. And what about J? Exactly half filled. So J will be equal to S. That is 0. Equal to S. That means 5 by 2. So it will be 6S 5 by 2. Similarly, calculate for the D7. What will be for D7? D7 means 7 unpaired electron. That means S will be 3 by 2. So 2S plus 1 will be 4. And what will be L? L will be 3. 3 means F. So it is 4F. Now it is more than half filled. So J value will be L plus S. That means 3 plus 3 by 2. So it will be 9 by 2. So 4F 9 by 2. Now for D8, what will the value for D8? For D8, 2s plus 1. So it will be 3. After solving, you will know L will also be 3. So J value will be L plus S. So it will be 3F. Similarly, calculate for D9. And D10. For D9, it will be 2D, 5 by 2. Because for D9, what is S? All are paired, but only one is unpaired, so S will be half. So 2S plus 1. So spin will be 2. L2 means it will be T. And N plus S, it will be 2 plus half. That means 5 by 2. And similarly for D10, it will be 1S0. Now moving to next. What is Laguerre polynomial? So Laguerre polynomial is given by L PQX equals to d by dx power P LQX. And what is this LQX? It is EX differentiation d by dx power Q E minus X XQ. Now for this, first we will simply solve for L11. This is simply for L11. It is given by d by dx LQ into X. Or we can say LQX will be given by Q is 1 and P is also 1. So it will be L1X. It is given by EX d by dx E minus X into X. Now there are two terms. How do you get differentiation of these two terms? So firstly we will differentiate the first term and keep the second term constant, then add, then second term constant and first term constant and second term differentiation. So it will be EX. Our differentiation of E minus X is minus E minus X. And second term is X, so it is as it is, plus. Now first term as it is. And what is the differentiation of X? Dx by dx. So, and Ex into E minus X, it is 1. So, it will be Ex minus E minus X, X plus, this will cancel out now. So, it will be only E minus X. So, Ex into minus E minus X is minus X. Ex into E minus X is 1. So, it will be minus X plus 1. Now, this value we know for LQX. Now, we have to put here. So, L11X will equal to differentiation of minus X plus 1. So differentiation of minus X will be this one will be the value. Similarly, let's solve for L21. So L21 means your P is 1, your Q is 2. Now we know this formula LP QX is equals to d by dx power P into LQX. So before solving, we should know what is LQX. So LQX will be EX d by dx power Q into E minus X into X cube. Now we have to know what is L2X first. So L2X is EX and substituting the values. EX is d power Q. Q is 2, so it will be d2 upon dx2 multiply E minus X into X square. So I'm just writing the equation first so that. So how we will solve this? For double differentiation. So we know it will be like we have to differentiate 2 times, so it will be EX. So first term differentiation. First term as it is. Differentiation of X square is differentiation of E minus X is minus E minus X. Second term as it is plus first term as it is and differentiation of second term. Now again differentiating these two terms. Like these two terms will again differentiate. So it will be EX bracket E minus X square as it is minus so plus now minus E minus X as it is. Differentiation of X square is 2X. Then plus differentiation of E minus X is minus E minus X. second term as it is, plus differentiation will of e minus x will be as it is. It should be constant and 2x is 2. Now after solving it, it will be ex multiply e minus x into x square minus 4x e minus x plus 2e minus x. So it will be x square minus 4x plus 2. Now L21x will be differentiation of the above term that we have got. So it will be 2x minus 4. That will the value. Now similarly solve for L13x. And also for the associated with the NS1. So that's all for today. So what we have discussed in today's class. So we discussed about the atomic spectroscopy, then Lyman series. Then this is a formula to calculate maximum number of spectral lines n2 minus n1 into n2 minus n1 plus 1 by 2. Then the Rydberg's formula. Then angular momentum is given by nh upon 2 pi. Then term symbol, that is 2s plus 1 L. So basically S is a spin, 2s plus 1 is your spin multiplicity, L is your total orbital angular momentum, and J value how you know, and L value if it is 0 it is S, if 1 it is P, for 2 it's T, for 3 it's F, and if it is less than half filled then L minus S will be J, if it is more than half filled then J will be L plus S, and if it is exactly half filled then J will be S. Then we discuss about the Langmuir polynomial, that we use these two formulas. L pqx equals to d by dx power p into lqx, and this lqx will be solved by ex d by dx power q into e minus x into x ki power q. So solve this L13. We will discuss in the next class. So that's all for today. Thank you. Do you have any doubts?